Next, let's talk about the experiment to determine the enthalpy change of combustion. We need a calorimetric methods, okay? A simple calorimeter is used to determine the amount of heat released during burning of ethanol or fuel. Now, you are going to carry out this experiment after the Lunar New Year holiday. So let's have a look first. First of all, we have a spirit lamp or spirit burner. Inside the spirit burner, we have ethanol, methanol, or propanol. That means the fuel. If we light up the burner, that means we are burning the ethanol, okay? Heat is released during burning of ethanol. In order to determine the amount of heat released, the heat released is transferred to the water inside a metal can. Use a stirrer and then measure the temperature change of the water. A polystyrene board is used to reduce heat loss to the surrounding. In this experiment, a certain mass of ethanol is burnt by using a spirit burner. Underline this sentence, very important. The heat released in the combustion of ethanol heats up the water in the metal can. Understand? This causes the temperature of water to rise. After 10 minutes, the burner is turned off. Extinguish the flame by putting a metal cap on top. The maximum temperature rise of the water is then measured. The amount of heat released during the combustion can be determined if the mass and specific heat capacity of water are known. Now, for physics students, you have learned this equation. For the others, please learn now. Heat released during combustion of ethanol is equal to the heat absorbed by water, okay? Which can be calculated by using this equation, which is the mass of water times specific heat capacity of water times temperature change of water. Now, would everybody please highlight? We are using the mass of water, then we have to use the specific heat capacity of water and the temperature change of water. Refer to the equation, which is equal to m, which is the mass of water, times small letter c, which is the specific heat capacity of water, and delta T, which is the temperature change of water. What is specific heat capacity? Small letter c of a solid or a liquid is defined as the heat required to raise 1 gram of the substance by 1 Kelvin. The specific heat capacity of water is 4.2 joule per gram per Kelvin. This is commonly used in chemistry, okay? The specific heat capacity of water is 4.2, pay attention to its unit, joule per gram per Kelvin. And then after that, we need to calculate the enthalpy change of combustion of ethanol by using this equation. Negative sign stands for exothermic reaction. Here, we need to use the heat released during combustion over the number of moles of the substance burned. Why do we need to over the number of moles of the substance burnt? It's because of the definition. Do you remember what is standard enthalpy change of combustion of substance? Is the enthalpy change when 1 mole of the substance is burned completely in oxygen. Okay, because I haven't mentioned about standard, so no need to end up with under standard conditions. Therefore, we need to use this equation to work out the enthalpy change of combustion of ethanol. Please refer to the video. Okay, by using the video, you can have a better understanding what is really going on. Okay, in this experiment. Now, let's use this example to explain the calculation. An experiment was carried out to determine the enthalpy change of combustion of ethanol by using a simple calorimeter. This is the simple calorimeter. This setup, simple calorimeter. We have a spirit lamp down below a metal can, and inside we have some water. Okay, heat released during combustion of ethanol is transferred to the metal, to the water inside the metal can. Initial mass of spirit lamp is 55.87 gram. Final mass of spirit lamp is 55.41 gram. You can use the difference to work out mass of ethanol burnt, which is 55.87 minus 55.41, which is 0.46 gram. That means we have 0.46 gram of ethanol burnt. Mass of water in the can is 200 gram. Initial temperatures of water 20. Final temperatures of water 28 degrees Celsius. Specific heat capacity of water is 4.2 joule per gram per Kelvin. Determine the enthalpy change of combustion of ethanol using the above data. Now, first step, please write down heat released in the combustion of ethanol is equal to the heat absorbed by the water inside the can. Do you understand? By conservation of energy, heat released in the combustion of ethanol should be equal to the heat absorbed by the water. According to this equation, heat absorbed by water is equal to the mass of water, I must emphasize mass of water, times specific heat capacity of water, times delta T of water. So, I need to substitute all the data for water into the equation. Now we have 200 gram of water times 4.2 joule per gram per Kelvin times delta T. Delta T, 28 minus 20, which is 8 in Kelvin. It doesn't matter in degrees Celsius or in Kelvin because we are talking about delta T. Use your calculator. Kelvin multiplied per Kelvin cancel out. Gram multiplied per gram cancel out. So 200 times 4.2 times 8 is equal to 6720 unit, joule. Okay, it is the amount of heat released in the combustion of 0.6 gram of ethanol. Now, according to this definition, we need to work out the enthalpy change of combustion of ethanol. In other words, I need one more step here. We need to calculate the number of moles of ethanol burnt, which is equal to the mass of ethanol burnt, 0.46 gram, over molar mass of ethanol, which is, the formula for ethanol is CH3CH2OH. Therefore, molar mass of ethanol, 2 times 12 plus 6 plus 16. .01 mole. Now, in other words, in this experiment, we have 0.01 mole of ethanol burnt. Therefore, substitute all these data into the equation. Now, because the reaction is exothermic, bear in mind, you need a negative sign. And then put 6720 over 0.01 mole. Again, use your calculator. A very large number, okay? Over 1000. You can change it to kilojoule, which is negative 672, pay attention to the unit, kilojoule per mole. Do you understand? This is the answer for this example. Understand? Now, down below, we have a self-test 34.1. Pause the video and try so that you can check whether you really understand or not. I will show you the answer later.